So, what does it really take to build a great science or math teacher for the 21st century? It's not just about memorizing formulas, it's about sparking that sense of discovery. Today, we're going to peek inside a fascinating, real world program that's designed to create exactly that kind of teacher. So, where does this blueprint come from? Well, it's from a series of advanced diplomas offered at Cypress International University in Liberia. And what's really interesting here is who it's for. This is specifically designed for junior and senior high school teachers who are already in the classroom. So, this isn't about training someone from scratch, it's about totally transforming and upgrading the teachers we have right now. And get this powerful philosophy is applied across 4 different advanced diplomas, one for physics, one for chemistry, biology, and mathematics. Each one is a pretty intense 10-month, 160-hour journey that's really meant to fundamentally reshape how these subjects get taught. Okay, so what's the secret sauce here? Well, the program is built on these core pillars. We're going to start with the foundation, the why of teaching. Then we'll explore the method, which is all about active learning. The how. We'll dig into the content, the what, and then we'll look at the art of the classroom itself. And finally, we'll see how it all comes together in a final capstone project. The program starts somewhere you might not expect. Before a single teacher touches a calculator or a beaker, they get grounded in the science of how we all learn. It's all about building that solid pedagogical foundation before you start building anything on top of it. So this is where every single diploma starts. Doesn't matter if it's physics or math, teachers dive deep into these core learning theories. You've got constructivism, which is the idea that students build their own understanding. There's behaviorism, which looks at responses to stimuli, and cognitivism, which is all about our mental processes. The point is, by understanding these, every other strategy they learn is actually rooted in proven educational psychology. Okay, so once that why foundation is set, the program pivots hard to the how. And this means focusing on modern teaching methods that get students actively involved, not just sitting there passively listening. And 2 really powerful strategies stand out here: inquiry-based and problem-based learning. The goal is to change the teacher's role from a lecturer into, like, an architect of curiosity. They learn how to design lessons that don't just hand over answers, but actually challenge students to ask their own questions and solve really complex real-world problems. The program also goes all in on the flipped classroom model. The idea is simple, but it's so powerful. Students get the core lecture material at home, which then frees up all that precious class time for what really matters. The hands-on experiments, the group work, and getting direct support from the teacher. And of course, technology is a huge part of this, but it's used with a very clear purpose. Teachers get trained on digital tools like PhET interactive simulations. These things are amazing. They let students actually see and play with abstract concepts, like how circuits work or how molecules behave. It's all about making the invisible visible. All right, so we've got the philosophy and we've got the method. But what about the actual content? What are these teachers learning? Well, the program makes sure that they are not only masters of the fundamentals, but are also fluent in the science that's shaping our world right now. And there's this really impressive dual focus. On one hand, teachers solidify their understanding of the foundational stuff. Newton's laws, the periodic table. But then they get pushed into advanced fields like quantum mechanics and biotechnology. The goal is to empower them to connect the basics to the really big, exciting ideas that are shaping our future. But being a great teacher, well, it's about so much more than just knowing your subject, right? This blueprint totally recognizes that. You also have to be a master of the classroom environment itself. It's really about the human element of education. So this part of the program is all about those practical, day-to-day skills. It spends a lot of time on creating inclusive classrooms, figuring out how to teach students with different learning styles, and, this is critical, using things like peer observation and reflection so that these teachers just never stop improving their own craft. So after months of learning theory, new methods, and all that content, how does the program make sure it all actually sticks? Well, it all leads up to one final, huge challenge, the capstone project. And listen, this is not just a final exam. It's a whole multi-stage process. Each teacher designs and then actually implements their own teaching project inside a real classroom. They collect data on how well it worked, they present their findings to their peers for feedback, and then they take one last, really critical step. And that final step is all about reflection. The goal isn't just to finish a project, it's to analyze it, to really understand what worked, what didn't, and what they learned about themselves as a teacher. This focus on continuous improvement, Well, that's the hallmark of a true 21st century professional, right? And that kind of leaves us with one final big thought. We've just walked through this intensive blueprint for building one highly skilled modern STEM teacher. So, what's the ripple effect? Think about the potential impact that one teacher, armed with all these tools, is going to have on the thousands of students they will inspire over an entire career.